So the first question was a big piece of code. It was, let's say, it said integer, triangle, n, I think it said colon equals new I equals n in new t equals 0 in do curly brackets while I is greater than 0 curly brackets t colon equals t plus I comma I equals I minus 1 and close brackets return t triangle 4 plus triangle 5. Okay, so your task was to basically make this into this proper syntactic form. This is what you might have written in the first year. I mean, you might have written your program and you think it's about right, it doesn't compile, and you think, oh no, what have I done wrong? And you have to go through and think, what have I done wrong? And previously you did it sort of informally, but now we've given you the absolute precise grammar. So now it's easy because you just follow the rules. Like I say, this is a great course for people who just want to follow the rules because there are lots and lots of rules to follow. Okay, so you've seen the grammar for imp, and I've got messages here, and we just need to follow the grammar for imp. So the grammar for imp says a program consists of, what is it? So this is the bit that's not on here, I'm afraid. It says a program is it's like a definition followed by a semicolon followed by an expression. Okay, so therefore I need to see a definition followed by a semicolon followed by an expression. And it's sort of here. So this is a program. This is how I would do it. If it's a big piece, I say, I need an expression and I need a definition. Well, this looks like my definition. And then this looks like my expression. But oh no, I need a semicolon. I think there's a semicolon I need. Yes, a semicolon. So there's a missing semicolon here. Yep.
Can we have the M up on there?
I think you might be able to. No, because there's only one of these which goes on both. So if I put the grammar on there, I can't do it here. But yeah, but I'll talk you through it. So, but you can see a program is a definition, semicolon, an expression. So that's what I'm looking for. So this is a fine expression. It's two things being added, and this is a variable applied to something, variable applied to something. So that's okay. So now we just need to have a look at this definition. So a definition can start with integer, and we've got integer, and then you have variable. That's fine. And then the grammar for a definition says I need to have open brackets, some stuff, close brackets. And there are no brackets there, so there's an error. So I need to put brackets here and brackets there. Now, inside the brackets, there's something called, what is it? Parameters. If you look at the parameters, that's a fine parameter, so that's okay. Okay. And then, if you look at a definition, you get an equal sign. But here, we don't have an equal sign. We have this colon. So that should not be there. And then after that, we have an expression. So now, inside here, I need to find an expression. So that should be an expression. And by the way, you know, when you write your programs and you press return, this is exactly what the computer's doing. It's got a definition of the formal syntax, it's looking at your parse tree, and it's saying, you know, is this now an expression? It goes further and further in and checks that things are the way they should be. Okay, so, is that an expression? Well, it starts with new, and new is the correct way to start an expression. So that's fine. So, a new expression, so the word new, and then you have variable, that's fine. And then you have colon equals. That just says equals, so we need a colon. Okay. In, have we got an in? We've got an in, good. And then we get another expression, so that's fine. So that means this should also be an expression. Right. Okay, is that an expression? Let's have a look at my list of things. Well, yes, it can be because it starts with new. Let's get it straight. Right. Okay. Right. So we have to have new. So we've got new. That's fine. And then we have a variable name, and we've got that. So we've got t. That's fine. And then again, we have to have colon. That's what the syntax says. And then we have to have equals, which we've got. And then we've got in. And we haven't actually got in. We've got into. So when we were typing this out, we jammed them together, and we forgot the space. So we need to replace this with a space. So this actually should be in, and then do. So, if we look at the expressions, now we've got a do expression. And so do has the form do, command, return, expression. So this thing must still be an expression. Right? And is it an expression? Well, we've got to have a command followed by a return. And that's what we've got. There's our return. There's our expression. So that means that we need to make sure that this thing is a command. Right, so you look at a command can be, well, here it says curly brackets. Can a command start with curly brackets? Yes, it can. The grammar says a command could be a curly brackets and then a block, followed by closed curly brackets. So there's an open curly brackets, so we need a block, and then we need a closed curly brackets. But if you notice, this curly bracket is going to go that one, so we're short of a closed curly brackets. So you need a closed curly brackets. So, next thing, right. So this needs to be a block now. So is that a block? Well, a block is either nothing, or it's a command, semicolon, a block. Well, this is certainly not nothing, so it ought to be a command, followed by a semicolon, followed by a block. And now if you look at it, so let's see, this is supposed to be the block. Right, that's supposed to be a block. So it could be a command followed by a semicolon, followed by a block, which can be nothing. So actually, there's a semicolon missing, and then you can have the nothing. Okay, so now, that means that this thing should be a command. Okay, so, when is while a command? So you need while, you need open brackets, a Boolean expression, a closed brackets, and a command. So, we need the open brackets and the closed brackets, and then we need a command. Yep. And you can see what I'm doing. I mean, I'm having to go back here. You can't possibly remember the syntax rules all the time. That's okay, they're in front of you. You can look them up, find out what you need, and then go over there and check that you've got it. Right, so now we need a command. And again, a command can be a block. So I've got the two things there. So then inside the block, I need a command, and then I'm done. I think I'm done. Oh, that should be a semicolon, and then I'm done. Oh, no, that should be a semicolon as well. Okay.
Should there not be a colon before the equals and I equals?
Oh, yes, very good. Of course, spot on. That was me just rushing the last bit because I was getting bored of it because it was trying to go. Sorry about that. That's the thing. You rush it because it's very delicate. Remember, a lot of work, but 100% accuracy, so it is a bit of work. You can rush it. If you rush it, you can get it wrong. That's why computers do this kind of thing. Okay, any question on that? Yeah?
Should not be a semicolon after the return T?
After the return T. Oh, you mean here?
Yeah.
Yes, there is a semicolon there. Any other questions? Any other errors in my answer that you spotted?
It's not meant to be parens around the like, triangle 4 plus triangle 5. The calls require.
Right, in here, in this grammar for imp, unlike in lamb, when you do additions, you don't need brackets. If you look at the grammar that you were given, you'll see it doesn't say additions are open bracket something, integer operator something.
I mean, triangle 4 should have parens around the 4, right?
Right here?
Yeah.
No,
No?
because this is an integer expression. It's just something at something.
Okay.
Take the class, Stuart.
Should.
Work harder. Yeah.
So does it not call triangle with the integer 4 as the parameter for it? Is that not why that would be the bracket shown 4?
Yeah, so you're right. In that it is triangle applied to 4. That's true. But unless I'm mistaken, and I'll check. Right. Okay. Okay, I haven't got the bit of grammar there to check, so I can't be sure. Maybe you're right. I don't think you're. Oh, actually, no, it's an application, isn't it? Yes, I think you are right. So that's why it's delicate. You've got to have the grammar, and I've only got a fragment of the grammar in front of me. Okay. Right, enough of that. Okay, what's the next question? All right, everything else is much easier because it's much shorter. So the next one was f, lambda x arrow s t. And the question was simply, so that's not well formed. It's not really clear what that means. That's not valid. Can you put brackets in to make it valid? How many possible ways? Well, looking at this morning, well, this could be f applied to take x as input and then return s applied to t. This could be f lambda x arrow s applied to t like that. So take x as input and return s, feed t as input for that x, and take the whole thing and give it as input to f. Or alternatively, it could be f, give that input lambda x arrow s, and then give it t. I can't think of any others. Is that any questions on that? I think that's fairly straightforward. Sometimes, just like we write 3 plus 5 plus 7, and we have an understanding of what that means, if I was to write f applied to s applied to t, there's a convention. It could mean this, or it could mean this, but there's a convention which means, oh shit, I hope that's not. There's a convention which says this. So I've heard Stuart tell it, several of you in the lab, says that application associates to the left. So f is more important, it's the function, so it grabs its input first. That's the first thing that happens. So if we don't write brackets, there's a convention which this is what we mean. So convention is something that's not in the rules, it's just we all have to understand it, which is why I have to tell you it. But if it makes a difference, we'll try and put brackets in. So this is a convention, and its application associates to the left. So that's not part of the answer, but since we have these two are an example of that. Without brackets, you don't know which it is, so these are both possible. Okay, next question. Right. Okay, write a grammar for Boolean logic. Your grammar should include formula which are variables, true, false, and combinations of formula using and, or, not, and implies. That's fairly easy, I think. So it's a grammar for Booleans, so I'll call them Booleans, equals, well, I've told you what there are. There are variables. Line. What else are there? There is true. There is false. Okay, combination of formula and, or, not, and implies. So you can have a Boolean and a Boolean. You can have a Boolean or Boolean. You can have, and if you see what I'm doing, I've given you all the information here. I've told you exactly what's in here. You just need to copy it down from the English into the formal syntax for grammars. So what's the next one? Not. So there's no point writing not after bool, it would look daft. Don't write it beforehand. And finally, implies. You could write the word implies if you like. I'm just going to write that symbol. Okay, so that's a very straightforward grammar. It's only got one type of thing, Booleans. You know, there's not commands and blocks and definitions, whatever. Yeah? Can you a little more quiet, please? I can't quite hear.
Would it still be okay if instead of not we write an exclamation mark?
Yeah, you can. If you want, you could write your not like that. These are just different. I didn't tell you how to write the symbol not, so that's up to you to choose. And you could have double ampersand, you could have the word and, anything you like, some syntactic way of showing which rule it is. Any other questions?
Is it okay to store true and false just as constants, like in a separate?
Yeah, exactly. So that's another option. So remember, in all of this programming and language design and implementation, there are choices. If there weren't choices, there'd be one language. So yes, of course, what you could have done instead here is written const as a separate grammar, and then what is a const? It is either true or false. That's perfectly fine. In some ways, that's better. You know, you could also have written, like with integer expressions, it says integer expression and then integer operator and then integer expression, just one line, and there's a separate grammar for integer operators. Similarly here, another alternative here would have been just to write bool, oops, and then a Boolean operator, and then a Boolean. And then I have to write a Boolean operator it's either and or I use your not. I can't do not like that, can I? Implies. And then I have to have not separately because it's not a binary operator. This is an alternative. And this is an alternative. Okay? Any more questions? Good. Sounds like you all found the homework, this handed okay? You're on top of it as well as I am. I won't go through the three options again. Just assume that's the case. Right, now for something slightly trickier. We said define a grammar where you can only use disjunctive normal forms. So remember, disjunctive normal forms are something or something or something or something or something or something. And you can have many somethings, one something, or no somethings. No, you have to have at least one something. Otherwise you don't have anything, and that's not a formula. Okay, and then each of the somethings is something and something and something and something and something and something, and you can have one or more somethings there. And then those somethings are either a variable or they're not a variable. So, being very good students who remember what disjunctive normal form is, I didn't write it down in the question, although I had to Google it myself because I can't remember it's and or ors and ands. There we go. Okay. So this is slightly more complex because you have to define several different grammars at the same time. So this is what I would do. So what's a disjunctive normal form? Well, it could be loads of stuff you've got already, or another disjunctive normal form. So it could be either a conjunctive normal form or a disjunctive normal form, or it could just be a conjunctive normal form. Yes! Who else wants to say yes? Anyone did not do this? No one wants to talk about it. It's okay to say you got it right or wrong. It doesn't matter. We're all learning here. Right. So I wrote this because, I want to get lots of or things in. Something or something or something or something or something. So I had to write or. Now, if I just write DNF or DNF, then, I'm just going to get lots of ors. But where do I stop? Okay. So I need to stop somewhere. I need to go down to the next level, the lower level, where you just have things and. So I did it this way. So I had, I can always stop with just a conjunctive normal form, or I can have a conjunctive normal form or another DNF. So if you think about it, until you stop, you'll get this or, one of these, so that's this or another one of these, this or, so you have a whole series of ors, and then at the end, you'll get another one of these. So that's why you get a sequence of conjunctive normal forms with or in between them. If you wrote DNF here, that would be fine as well, because you'd have or and you have two things and you split them all up, and eventually all of them, when you stop, would have to turn into conjunctive normal forms. So it's okay to have DNF here as well. Right. Okay, now what's a conjunctive normal form? Well, if you understand that, this should be fairly straightforward. Well, it's going to be a whole load of and things, and you can have more of these conjunctive normal forms, but at the beginning I want to start with the literal, and of course I can always just have a literal. So if you look at one of these things, you're going to get, well, let's say you use this, either you'll start with a literal, or you'll have a literal and another thing, maybe a literal and another thing, maybe a literal and another thing. A whole sequence of literals with an and eventually you'll stop with a literal. And again, had you written that would be okay as well. I mean, you have different expressions, but they'll all represent conjunctive normal forms. And then what's with all these literals? Well, it's either not and a variable, or it's a variable.
Doesn't there have to be brackets around conjunction or DNF and let and conjunction? If that makes sense. Because otherwise,
I
you
don't
could get
think...
like A and B as a DNF, could you not?
No, because if you look at DNF, it has to have an or in it, so you're not using this rule.
But what if you just use conjunction? and then you can get.
Okay, I'll tell you what, if you're not sure, put in brackets. So, right, tell you what, I'll think about that. I don't want to work it out and give you the wrong answer by accident. So, okay, brackets. All right, maybe I'll ask you guys then. So, who thinks we should have some brackets in here? Well, many of you. All right. And who doesn't? Okay. Well, being a loner, I don't mind being wrong. I won't take. I don't mind that. So I'll check and I'll give you a proper answer. Right. Right. Normal forms. So we'll give you answers written out properly, so you'll get an answer to that in that way. Right, normal forms. So, now that you've been doing this section of lectures, you know why these normal forms are important. These are the things that you can't do any small step reductions from, because they contain no beta reductions. But can we define those as a grammar? Yes, we can. So, this is what I did. So what is a normal form? Well, it could be a variable. They are normal forms. It could be a lambda abstraction, providing the body is a normal form. And it can be an application. But we have to be careful. If it's an application, we might say, you know, f applied to A, and f is a normal form, and A is a normal form. That's almost right. But we also don't want f to be a lambda abstraction, otherwise you've created a redex. That's why we have another category for neutral terms. So these are normal forms. And a neutral term, remember this is a normal form that is not. Sorry, that's a neutral. That is not a abstraction. Right. So that's okay. So what's a neutral term? Well, variables. These are normal forms. They're not lambda abstractions. If I had a variable here, this would not create a redex, so that's fine. They're not lambda abstractions, so I can't do any lambda abstractions. And of course, they could also be applications. So what would that mean? Well, to be an application, I would want the second part to be a normal form, but of course, I want the first form to be not a lambda abstraction. So I need a neutral term here, not a normal form. Okay, any questions? Right, no questions? Everyone happy with that? Ask now or not learn? Cool. Okay, nearly done then. So the last question was, as you'll see, now it's our reductional. So we have a particular grammar. X, A, oops, there's an A, and then it's a, what is it? It's a Y. B, or it's a C, or it's a BXK. X, A. And then, what's a Y? Y is a C, and then an X, and then a C, or it's an
Half
A.
the angle brackets.
So we want all the valid expressions for x of length 6 or less.
Yes, you're right. Yeah, that's right.
Okay, so we just start with x, and we use any production rule we want. Yep.
I think for y on the first line, we have the angle brackets from the C.
Shit, I wrote it wrong, didn't I? Those of you who are very careful, very methodical, and take your time, you'll love this course. Those of you who are like, zip through it, like me, you'll make errors like that. Okay, so we want all expressions of length 6 or less. So, we start with x, and we just start using these rules to see what we can do. So one option, and I think we should just explore methodically. It's like when you do a truth table, you write down all the possibilities and just go through them. So let's say we use this rule first. So you can have x goes to a y, b. Okay, that's fine. Then what can we do with the y? Well, we could use this one to go to a, c, x, and then c, b. And what can we do with the x? Well, with the x, if we use this rule, we'll have 6 symbols, and we'll have to do at least one more, so use too many symbols. Similarly, we can't use this one, so the only final one we can do is use the C, A, C, 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 B. Now here, okay, going back one, when we had to expand the y, we used the C's, but of course we could have used an A. So an alternative would have been to go to A, B. Y could become an A. That's the only other alternative. So here, going back again, there we used this one. Well, of course, we could have used this rule, C, and then we have to stop because there's no more x's or y's. Or we could have used B, X, A. Now what can we do with this x here? Well, there are 3 options. We could use an A, Y, B. So we have B, A, Y, B, A. And then this y, we can't go to 2 C's because that'll be too long, so it has to go to an A. We've got B, A, B, A. Alternatively, instead of turning this x into a y with this rule, we could use this one. So that could have gone to a B, C, A, or finally, almost finally, this x could be expanded with that one, that rule. So we get to, of course, it's B, and there's an A, there's a B, and there's an X, and there's an A, and then the only option is B, B, C, A, A. So, again, if you think about what we did there was no creativity. I just followed the rules. I just looked at all the different possibilities, I went through them in logical order. Can I not just have C? Yeah, I can have C as well. Yeah, here it is. That was when I did C. Yes, I'm very glad to be on my toes. That one I got a flip. Alright, this room. So let's see. So what's the next time I see you? So I'm going to see you on Tuesday next time. The next homework will be on reduction that we've been doing. And then after, we'll have one more lecture on reduction. And then we're going to do typing. And that means one more lecture. We've reached halfway through the class. Woohoo!